This is section 3.1, quadratic functions. One important thing here is that we're going to be practicing skills in this section that are critical for later topics. You do not want to rely on your graphing calculators to give you the answer here because you're not getting the practice you need if you do that. This section is about more than finding solutions. So keeping that in mind. Okay, so we talked back in the last chapter about a general quadratic function. It was f of x is equal to x squared. We know that its basic shape was a parabola. And we talked about shifting it up, down, left, right, all that kind of stuff. Okay. Now, we're going to be talking about more general quadratics, not just the most basic one. What we have is what we call standard form, and it is a quadratic written in this form, where f of x is equal to a, where a is just some number, x minus h squared plus k, where a is not equal to 0. Basically, we have to have an x squared in the formula. If we don't have that, then we don't have a quadratic, okay? If you look at this, what we talked about when we were doing this section was that this value was your up-down movement. It was a vertical shift. This was a horizontal shift, left to right. And this a is just a multiplier, and it would do the shrinking or stretching, that part that we didn't really cover that much, okay? Now, if we have something written in this form, the vertex of the parabola, which is the point where it changes directions, wherever that is, the vertex is the point HK. So the k is our vertical shift. Notice that that's plus k. This is a positive k. Remember, our horizontal shifts seemed backwards because of the minus sign. And just like also within the circular formulas, this is a minus h, so this is a positive h. Okay. All right. All parabolas are symmetric, but maybe not over the y-axis. Okay. We have what we call the axis of symmetry, which is an imaginary vertical line that passes through the vertex. Wherever this line is, we could fold one side of our parabola over onto the other and have them match up, okay? The axis of symmetry is always a line that is x equal to h. This h is this h right here. X equal to must be there. If you just tell me that your axis of symmetry is 2, that tells me nothing. 2 is a number. 2 is not a line. It has to be a vertical line, and vertical lines always have the x equal to on it. So x equal to whatever your x value is. So if this goes through the point, say 2, 3, if that's my vertex up there, then x equal to 2 is the equation of that vertical line. Okay? Now, if a, which is the multiplier, if a is greater than 0, so if a is a positive number, the parabola opens up. So it's going to have this basic shape. If the number in front is a negative number, if it's smaller than 0, then the parabola opens down. So it's going to have this basic shape. Or it's going to be reflected over the x-axis, the way we talked about before. Remember, if this was a negative in front, it flipped it up and down. And that's all we're talking about here. We're not talking about the actual number value here. We're just talking about whether it's positive or negative. Okay, so let's just go through a problem like this and just identify all the different pieces, not worry so much about actually getting a graph. Okay, so we're asked to find the vertex and the axis of symmetry, which I'm just going to call axis, and then how it opens. Okay, well, to find our vertex, we need h and k. So if we look here, my h, this is minus, so our h is positive 2. Our k is positive 12. And our a, which is the multiplier in the front, is negative 3. Now let's use this to find this. Our vertex is the point hk, so the vertex is 2, 12. The axis of symmetry is x equals h, so our axis is x equals 2. h2, this is our x value here, is what goes right here. And how does this open? Well, my a value is -3. -3 is less than 0, so the parabola opens down. Now, the good thing about all of this is stuff you can tell just by glancing at the equation. We don't have to know all of the specifics, but we can tell very quickly that this is where our vertex should be. It should open down, and it should be symmetric about this. Now, why is that useful? Because eventually you're going to be using graphing calculators for these, and it is incredibly easy to make a mistake when you're typing in the equation you want it to graph. If you are blindly trusting your calculator and you make a little entry mistake, you're going to get it wrong. Whereas if you can look at this and get an idea of what your graph is supposed to look like, you're more likely to catch those mistakes because you have a basic idea of what to expect from your graph. Okay, so let's just talk through the whole process of graphing a quadratic. First thing we want to do is we want to determine the direction that the parabola opens. How does it open up? Does it open down? We want to find the vertex and the axis of symmetry because that's going to help us get our graph very quickly. Okay. We're going to find x-intercepts if we have any. Remember, we set to find x-intercepts, you set y equal to 0 or f. You find f of 0. That's the other way of thinking about it, depending on what notation you have your equation given to you. Find the y-intercept. And no, let x equal 0, sorry. If x is 0, find the y-intercept. Sorry, messed that up. So what we're going to have here, our parabolas are always going to cross the y-axis because there is no way to draw a parabola that doesn't cross the y-axis somewhere. And we're dealing with functions, so we should only ever have one y-intercept, because if we have more than one, we don't have a function. It doesn't pass the vertical line test. But it is possible that we don't have any x-intercepts. If I draw my parabola up here, I never cross the x-axis. It is possible that we have just one, where our vertex would be on the x-axis, and it's possible that we have two. That's all we would have to do like that. So for the x-intercepts, we might have none, we might have one, we might have two. We'll never have more than that. Okay, so what we've got here is once we have all this information, we should have a good idea of what our graph is going to look like. We will plot our intercepts, the vertex, drawing the axis of symmetry, plot additional points if we need to, and then we'll connect them with a smooth curve to get a graph of our function. So let's just do this. We're going to graph using the 5-step method above. Our first step was how does it open? Okay, so let's look at this real quick and decide our A, our H, and our K. Well, our A is the multiplier in front, and there's not one listed there, so it is an understood 1. Our A value is 1. H is right here. Remember, it's going to be the opposite. So this is a -1, so our H is +1. And our K is from right here, -2, so our K is -2. Okay, so how does this open? Well, our A value is a positive number, so this one opens up. Okay, 2 is to find the vertex, and then the axis of symmetry. Well, our vertex is HK, so this is 1, -2. And our axis of symmetry is x equals whatever our x equals here, which is a 1. Okay, now part 3. 3 was to find x-intercepts, if there are any. So what we need to do is we need to take x minus 1 squared minus 2 and set that equal to 0. Now to solve this, I'm going to add 2 to both sides. I get x minus 1 squared equals 2. Now I can use the square root property to solve this, meaning I need to put in a plus or minus right here. And I get x minus 1 is equal to plus or minus the square root of 2. Now add 1 to both sides, and you get x is equal to 1 plus or minus the square root of 2. Okay, now if you were asked just to tell me what your x-intercepts are, you would tell me your x-intercept is 1 plus the square root of 2 and 1 minus the square root of 2. Okay, now we need to be able to plot these, so you want to plug them into your calculator and get an approximation, something you can approximate on your graph. And if you plug in 1 plus the square root of 2, you get about 2.4. And if you plug in 1 minus the square root of 2, you get about negative 0.4. Okay, so we'll be able to plot those. The fourth step was to find the y-intercept, which means finding f of 0, plugging in 0 for x. That will give you negative 1 squared minus 2, or 1 minus 2, which is negative 1. And then our fifth step is to graph. Okay, so I know my graph is supposed to open up. I'm going to use this as sort of a check step. All of the rest of this should force my graph to open up, and if it doesn't, then I know I've made a big mistake somewhere. I need to go find it. Okay, so the vertex is 1, negative 2, which is right here. Now your axis of symmetry is the vertical line x equals 1. What you want to do is you want to draw in a dotted vertical line. I'm doing it slightly off to the side, hoping it will show up. And it is the vertical line that passes through the vertex. This is the line about which my graph should be symmetric. So basically, if I find out I have a point right here that's 1 unit away from the line here, it would also be 1 unit away on the other side. That can help us a whole lot to get extra points if we keep symmetry in mind. Okay, so I have done my vertex, I've plotted my axis of symmetry. My x-intercepts are at about 2.4 and about negative 0.4. Well, 2.4 is about right here, and negative 0.4 is about right here. Notice that they are symmetric about this, which is good. My y-intercept is at negative 1, which is right here. Okay, now graph. Often what will happen, well, every time essentially that your the axis of symmetry is not the y-axis, you're going to be able to double your y-intercept. So I got this point with my y-intercept. I can use symmetry to get this point as well. Now, depending on where your graph is located, particularly if you didn't have x-intercepts, you might need to plug in some other values. You can't pick something that's wrong. If you want to plug in 3 for x and see what you get, you can use that. Okay, so you can't pick a wrong number, but these are the ones that will generally get you your graph. Now you want to connect these with as smooth of a curve as possible. We're not all artists, so just do your best. Just know that it does not come to a very definite point like the absolute value function. Now our graph, because of the points we found, it did force our parabola to open up, so this is sort of a check in there. This is the answer to our graph.